Hello and welcome to my YouTube channel. And this is going to be part three of the NX bridge in HO scale, which is the project is a modification of the Walthers Bascule Bridge kit and then a Fremo module that the bridge is going to sit on. Part one, I talked a lot about the history of the prototype that I'm semi-basing this on and the challenges of the project. So this video is going to focus on the getting the mechanical operation of the bridge worked out. You can see the white acrylic in the on the bridge. That's the stuff that I built to operate the bridge. So here you're going to see me testing it out. I've tested it many times, but this is kind of the final configuration, and it's only jerky because I'm just touching wires together. But you can see it's running really smooth. It uses an incredibly small motor with virtually no, I forget what the milliamps that it draws. It's like nothing. It's also, I think, a 20 RPM motor. It's a gear motor. And so the whole swing of this bridge, and you see how high up it is. That's how high it has to be for correctly to. I've seen other people modify them. I think they use like servos or some kind of arm on it instead of the Walthers drive, and they only go up about 45 degrees, which isn't correct for this Bascule bridge. So back to the motor though. It only, I think, maybe fully turns 6 full turns to raise and lower the bridge. So it's not going to create a lot of force on anything. And even now, I don't have any of the rear structure built. So I have to, and that'll actually counterweight things a lot. So it can pull it up without the extra weight. So here you can see my drive that I created here. It's all done with acrylic, laser cut acrylic that I designed. I'm basically using sandwiches of acrylic to create the gears, gluing them to shaft collars. They're all 3mm shafts. The motor's a 3mm shaft. I'm gluing them with a JB Weld, which is really tough, and I think it'll hold up. And nothing of this is tried and true. And then you can see the arms have to pivot inside the structure. That's why this structure is a little bigger than the Walthers structure, because the arms are inside the structure. So it's a little higher. I got some ideas of how I'm going to kind of camouflage that with some walkways and things like that. You can see the arms are, again, sandwiches of acrylic that have gears. There's a gear rack that I laser cut on the bottom of that. There's some plugs there for connecting everything in case I have to disconnect the motor or disconnect the other plugs go into a limit switch on top of one of those movable, the kind of like guide housings for the arms. Those guide housings tilt as the arms go up because basically the geometry of everything changes as the bridge raises. The arms are at different angles, so all the guides and everything have to be designed, and that's what took so long. You can see there's a tray of some of my failed parts, all kinds of crap that didn't work. The good thing about a laser compared to a 3D printer is laser is super fast. So when you do something and then cut it, you try it out on the bench, you try it out, see if it works, and then you can redesign it and recut it quick. If it's a 3D printer, you're going to be sitting there for an hour or two waiting for a new piece. So you can see this is kind of, a lot of these designs are not being used anymore, but that's kind of where I started. I even deleted some stuff in here, so that's kind of how my design process works. I just have the one program and I just draw everything on there, because sometimes I got to go back and like pull the old stuff, so I don't delete anything, I don't clean it up. I try to keep it all out there. Because in the past I've cleaned things up and then deleted them, and you know it just doesn't, it does, then I need it all of a sudden, and it's harder, you can't really pull it back up at that point once you've cleaned up the drawing. So that's why you see a lot of them that have all the lines through them and everything. There's a drawing I have there. I traced the bridge, and I'm actually drawing that now. Here's some of the components I use. The motor, those are the screws to mount the motor. The motor is mounted with M 1.6 millimeter screws, which are pretty freaking small. You can see those are the lock washers for the motor mounts. So you gotta bolt it together with tweezers basically. But I use metric on everything. My laser cutter understands metric. My design program, I design everything in metric. And believe it or not, everything available online is available. You have more availability of metric parts on Amazon and eBay than you do of standard parts. There's the motor. So you got an idea of the you know, it's at some point I'll probably get into the actual how the mechanism. I mean, it's pretty simple. It's just some gears and it turns a gear rack, just like the Walthers kit. But the gear rack's a little bigger. The teeth are a little bigger, so there's fewer teeth, which is one of the things I wanted to do to create it, make it more reliable. But I figure having fewer teeth and having fewer turns of the motor, less wear and tear, and that's what my concern was. A tiny Walthers Delrin gear would just grind down one day if something got stuck, and it would be impossible to fix. So I wanted something, all these parts unbolt, so I could just unscrew everything and put in a new part. That slot was part of the original design. I was going to put a nub on that to trigger the limit switches, but you can see those limit switches up there now. They're actually on the top, so I'll have to just glue a piece of plastic along the top. So now we're at my original, kind of getting back to the beginning here. This was like the first set of gear rack that I designed, and gears, and those gears with the big internal sections are whole or too fragile to glue up. They kept splitting on me. The gear rack itself is very close to the Walthers gear ratio, which was what I was trying to get away from, but that's how I ended up starting out, pretty close. You can see the two of them side by side. The black is the OG Walthers one, and then you could see my rack on the bottom. And in reality, the rack faces down, so you're not going to really see it. And I don't know how close the Walthers is to prototype. I know mine's probably a little bigger than prototype, but the real one might be somewhere between both of ours. I'm not sure the Walthers is, the bridges that I've seen, it seems a little coarser than what's going on with the Walthers bridge, the gearing. So I did increase the size of that, and I also, like I said, wanted to reduce the number of rotations of the motor, so I could control the motor, and the nothing would be under a lot of stress. Just like a nice slow movement of everything, all the gears meshing, nothing heating up. So, but with the original, or this was, I think, the redesigned gear rack, and here you can see me, I glued one of the gears themselves up, and I'm kind of like manually like fussing around to see, yeah, hey, this will actually work. This is not going to be beyond what I'm capable of doing. And that was like a month and a half ago. So, from that point, some of the little mechanical stuff associated with this and the geometry issues really kind of, came out. And at that point I said, well, the Walthers guys, the engineers that designed that model, the product design guys that, or girls, I'm not sure, knew what they were doing. Again, but they designed it around a shit motor and shit gears. So just for cost, obviously. So there you can kind of see this is the rack I ended up using. You can see the coarseness of it. I think I have about 100 and something teeth for the whole length of it. And I think my gears are maybe like 16 to 20 teeth on the small gears. So again, it only has to spin like 6 times or something, 5 or 6 times to travel, to extend the gear rack the length that I need to operate the bridge, so it's fully open. Everything is sandwiches, so the rack is I think like 5 pieces are acrylic, 16th inch acrylic 060, which is 1.5 millimeters, glued together. And then the gears are sandwiches of, I forget how many pieces, but everything's a sandwich. So now to make it easier to kind of join the sandwich together and make sure that everything stays in alignment, since I'm dealing with gears here, you can see these holes that I just designed into the racks. I just put a bunch of random holes. I don't think they're maybe like 1/8 inch or 16th inch, 16 of an inch, something, that I can slide in a styrene rod to kind of align the whole thing as I'm gluing it up. Styrene bonds to acrylic awesome, like real fast. Acrylic bonds to acrylic. If I use Plastistruct, the orange Plastistruct cement, it has to sit for a little while and I have to clamp it sometimes. It's slower, but it's more controlled. I do have acrylic cement, which is like super fast. It's actually too fast. So I usually use the orange Plastistruct cement to glue up the acrylic. I have to sand the face so it's not shiny, and then I just have to be patient with it. But I'd rather have a more controlled glue up than that instantaneous, like I think that other stuff's like 30-second bond or something. It's capillary, so you can hold everything together and it just sucks into the seams and glues everything, but it's crazy fast. It smells freaking horrible. Not that I used to use dope, not dope drugs, but if any of you know, nitrocellulose dope to seal, Pinewood Derby cars when I was a kid. So I've been inhaling solvent glues and paints my whole freaking life. So it's kind of beyond, worrying about it at this point, but it's still, don't want to breathe it if I don't have to. So there's the, one of the first roller designs, because again, you can't have like a fixed gear in the motor house in like a fixed position, because as the bridge goes up, that angle that gear rack is at changes. It's constantly changing. So the gear housing that drives that thing has to move with the rack. So this was one of my first designs. It uses some ball bearings and spacers and bolts and everything. And believe it or not, this did not work as well as I thought it would. It kind of bound up a little bit. It would get kind of sticky and fussy. On the bench, it worked great, but when I put it on the bridge, it didn't do so good. And you can see the gears kind of contained there. Just too many things. Like it could wedge for some reason. Like I don't know if it needed to be looser, the whole thing just kind of loosey goosey, or for it to work right, or what. But I couldn't. I tried about 3 or 4 different iterations of this to get it right. In the back left there, you can see how I build the gears. You can see it's like 3 pieces of acrylic sandwiched together for the teeth, then another round piece, and then like kind of a washer, and then I put the collar, what are those called? I don't know, shaft collar in it. And that shaft collar has a little Allen nut, and that's how I secure it tightly to the shaft, the motor shaft. So this is, I think, what I actually settled on, which actually doesn't use any ball bearing guides. It uses just plastic. This did get modified one further time because I decided, hey, I could put the limit switches on these things, so the limit switches move with the rack, which would be great. So they're always in alignment. So I added a little wing that came out of this that the limit switch bolts to. And it seems like it's working great. And I have a backup limit switch too, because I put one on each arm. There you can kind of see kind of fitting these guides together, the gears. This is kind of everything. There is one gear that's bigger. The gears that drive the racks are the same size, and the gear on the motor is the same size. And then there's a larger gear on the motor shaft that the motor gear hits, and that gives me a ratio that slows everything down. So it gets me like it's a 4-to-1 ratio. So I go to like basically from, I think I was at 20 RPMs the motor, and I go down to like, whatever, 5 RPMs now, which is what I said. I got 20 teeth on the gear or whatever, or a little less than that. But that'll give me the full run of the rack in 1 minute, which is about appropriate looking for the bridge going up. I mean, you saw the video at the beginning. It looks pretty good. So taking pictures of your work is really important. If you look at this picture, I took a close-up. I didn't even see this. This was everything was running fine. Everything was great. But if you look at this picture closely, you can see that motor mount. The motor's kind of canted. It's actually bending because of the torque and everything. The motor is bending, so that's one of those things where you go back and you just redesign it. And I went back, and all I did was just add like a little flat part to the front, like a support, a gusset, to keep the motor mount stable. The motor stable and the motor at 90 degrees to the shaft. But if you didn't take that close-up picture, you would never see that. So it's always really good to take close-up pictures of your work. With a phone, it's no big deal. And then zoom in, and you'll see every imperfection that you're missing with your eye, and you can fix everything. So you can see here, we're about wrapped up for this video, but I'm moving on to the structure now, and that'll be the next video. It'll be about modifying the whole structure to match the NX bridge. And I kind of laser cut a couple profiles. I put the Walther's bridge into CAD, and then I'm creating my framework for my stuff. And you can see that first one, the counterweight, didn't look right. So I kind of redesigned it, and this is kind of the final design that I'm using. So thank you for watching this video, and part 4 will be on the structure and some of the other work on the module. I'll probably be doing the Fremo stuff and the bridge in the same updates. So stay tuned. Thanks a lot for watching. Take care.